Here is the first one. A stone is dropped out of a rising balloon from a height of 100 meters. If it hits the ground in 20 seconds, find the velocity of the balloon. Just because it says it's dropped, that doesn't mean that the initial velocity is zero. No. The initial velocity of the stone is the velocity of the balloon, which we are trying to find. Okay. So to save time, initial velocity is what we're trying to find. A we know is negative, right? Yeah, meter per second squared. What is the height? Isn't that what we call delta y? Is it positive or negative? It's coming down from a height, the stone is. Well, of course, the stone will go up a little and then come down, but we don't care about how much it goes up because it'll come down by the same amount, canceling out. So all we're interested is the negative of that height, which is 100 meters, so negative 100 meters. That make sense? Okay, and the time is given, so 20 seconds. So when you see that, you know the formula. Do you?
Yeah,
The king. The king. All right. So substitute into that. Yeah, that's an impossible thing, but for the sake of the question, let's assume that it was fired with a rocket or something. All right. That's our second topic. Take a look at this. You have two connected masses. Do you remember this?
Yes.
Yeah, two connected masses connected by a string passing over a frictionless pulley. You got to find the acceleration of the system and the tension. Okay. The one reason why students struggle on this especially is because they try to memorize. So let's take memory out of the game and you be listening to me. You have to draw a free body diagram, which means you look at one object at one time. So you imagine the other one is absent. So let's look at this. The bigger object we know is going down. So focusing only on this, what are the forces on this? Don't even look at what's written. Just its weight is acting down, which is mg. There must be a tension in the string acting up. So by Newton's second law, the net force, which is mg minus ft, should be equal to its mass times a, which is what I've written here. Look at that. There's no need of memorizing that, correct? And for the second one, ft will be the same because it's the same string. And ft will be acting up, isn't it?
Yes.
But the weight always acts down. So what's the net force on this? ft minus mg is equal to little m times a. Now, when we do this, we're not considering the idea that up is positive, down is negative. We could, we would still come back to. So we're just looking at the bigger force minus the smaller. For the little one, the bigger force is the tension, the smaller one is mg, correct? Once you get the equations, these two equations, then you can find the acceleration just by math. You know what I did here? I added the two equations. So the negative ft and the positive ft cancel out, leaving us with this on the left side. A is common here, that's taken out. Divide throughout by this, and you have the acceleration. Once you get the acceleration, can you put it into one of these equations to find the tension?
Yes.
Yes. So we're not going to put numbers there and spend a lot of time because that will just be a waste. So look at this and ask me a question now if you didn't understand. This is the third topic. One object moving vertically, the other moving horizontally. There is no friction in the first part. But if I bring in friction, I'll talk about that later on. So the first part, there's no friction. So can you tell me if this formula or these equations are written with friction or without?
That's without.
without. Now, why do we have to memorize? Is there any need of memorization? Look at this. So first, no matter I say, how many times I say, you have to understand, this is the object we are looking at. What are the forces acting on it? mg and tension. So mg minus tension should be equal to m times a. So easy. Unless you're trying to memorize. Okay, look at this object. What is the force acting on this?
Tension.
Only the tension. Why? Because mg and normal force are along the y-axis. And we are looking at the motion along the x. And we know the x and the y, they don't affect each other. See? Therefore, the force on this is just Ft. Therefore, Ft is m times a. Because there is no friction in this part. Did you understand that? If you consider friction, friction only acts on the smaller mass. And friction is always opposite to its motion. Therefore, since the smaller mass is trying to move to the right, friction should be to the left. And what is the formula for friction? Friction is mu k times Fn. Mu k times Fn. What is Fn in this case? Fn is equal to mg. Fn is equal to mg. So friction is mu k mg. Therefore, well, is this equation going to change? No, I mean with the... Nothing happens to that one. It's only the smaller one, so I wrote that down. Does that make sense? Ft minus friction is equal to m times a. And you're good. You're done. Here is something connected to that again, but this time it's an incline. That's all. Right? So if it's an incline, what do you need to do? You need to fix your x and y axis. Do you remember that we always take the x along the ramp and y perpendicular to it? See that? And then for this object and this, now you got to be very careful about, I've drawn this friction a little off so you can see it, okay? Not that I made a mistake. It's supposed to be on that, then you won't see it. Okay. So let's look at this. Will this change? No. So when we talk about the x and the y axis, we're only talking about the one that's moving on the ramp. This one is like always, mg minus ft is ma. Okay, good? Right, this one, Fn should be perpendicular to the ramp, which is along the y-axis. Weight should always be vertically down. So you're going to break the weight into the two components. Remember, we did that so many times. Mg sine theta and mg cosine. And then friction is always opposite to the motion. Since the object is trying to go up, friction should be down. So what are the forces acting on this totally? Isn't there Ft minus friction? Right? And there should also be what? Mg sine theta. So look at this one, not this one, okay? Look at this. Ft minus F minus mg sine theta is equal to ma. Everybody understood that? I'll just cross out this one so it doesn't confuse you. Okay. You don't even have to write that. Ft minus F minus mg sine theta is equal to ma. And what is friction? Like before, friction is mu k times? Yeah, no. Be careful. It's not mu k times mg this time.
Mg cosine.
Yeah. Mu k times mg cosine theta. That's where you got to be careful. Yeah. Because it's on a ramp.
So when it's on a ramp, it's supposed to be mg cos theta,
Yeah.
not mg sine theta.
Mg sine is along the ramp. Okay, so here you have this supported at 2 points, 2 supports here, 1, 2. These are the reactions at the supports, and you have 3 forces. And this force may be the mass of that or the weight of that beam. Now that's something that students forget. Do not forget. If I say it's a uniform, whatever, a beam, its center of gravity is exactly at the center, so don't forget that. Okay. And then I ask you to find something. Let's see. Here are the conditions that I told you. Net force must be 0 and net torque must be 0. So here are the forces. So when I say the net force is 0, that means F4 plus F5 is equal to F1 plus F2 plus F3. All right. What should you remember in this case? The most important thing to remember is, you can calculate the torque at about any point, but you should always pick one of the supports as the pivot. You could have calculated the torque about the left end, here, right end, so you have to pick either this or this. Did you hear me? Okay. And now, so easy in the sense, look at this. About this point, isn't F2 trying to turn it clockwise? F3 also clockwise? Right? F2 and F3 trying to turn it clockwise about this point. Like, I'm talking about two forces here. 1, 2 trying to turn it clockwise. What is the torque due to this force? 0, because there's no distance. Okay, so that is gone. This one is trying to turn it counterclockwise, isn't it? Mm-hmm. So is this one. Do you see that? You got it. Torque is force multiplied by the perpendicular distance. Look at which ones are clockwise, which ones are counterclockwise, and then start looking at it. So that's clockwise, this is counterclockwise, these two. Okay. So the points are A, B, C, D, H, so I can write it. I want to show the distances. F2 times BC plus F3 times BE should be equal to F4 times 0. I don't know why I wrote that, just to show that it's 0. F1 times AB plus F5 times BD. Done. It's again static equilibrium. We've done this so many times. This kind,
Oh, God.
where you have a mass supported. This is one of the easiest things, actually. You have a mass, 10 kilograms or whatever, supported by 3 strings, knotted here. The angles θ1 and θ2 are given. You should be able to calculate the tension in the two parts. Right?
Mm-hmm.
In this case, there is no need of even considering the torque. It's only forces. This point is not moving, is it? If this point is not moving, the forces along the y and along x must both equal 0. That's it. Net force along x, net force along y must be. So we got to first set it up. Okay, first set it up. I call that T1. That tension is T2. And wouldn't this angle be the same as this?
Mm-hmm.
So since I drew that, and this is T2, wouldn't this be T2 cosine θ1?
Mm-hmm.
Who understood? Yeah, and this would be T1 cosine θ2. So don't go between, you said it's sine, you said it's cosine, because sine 30 is the same as cosine 60. Who understood? Yeah, so sine 30 is the same as cosine 60. So what I'm saying is the same thing. You cannot memorize. You cannot. It'll work in a lot of subjects, not in physics. Okay. So those are the terms. If I take those angles. Who understood? Okay, good. So add up those two equal to mg, and these two should be equal to each other. That's it. Yeah, that's the general condition. Net force along the x and net force along the y should be 0. T1 cosine theta 2 is T2 cosine. If you try to memorize, it'll be funny. You can hear somebody reading T1 cosine theta 2 is equal to T. No use. I'm going to change something on the final exam, and then you'll be like, God. Carnot's engine, which is such a favorite for students, so easy, heat engine. We jump from there into thermodynamics. You see, I'm not following a particular order. What is Carnot's engine? It takes heat from a source, converts a part of it into work, and rejects the remaining to the sink, right? That's it. Look. It takes QH joules of heat, converts that much into work, and rejects QC. All right, somebody tell me what's the formula for work?
QH minus QC.
Work is QH minus QC. Because if it took in 1,000 joules and rejected 300 joules, then what got converted into work was 700 joules. Did you hear me? That's the work. How do we define efficiency? Work over, it's output over input. Output is work, input is QH. So efficiency in this case, there are three formulas. One is that, but since we know work is QH minus QC, you can substitute that and you will get another formula. And then the third one is TH minus TC over TH. Done. And usually it's, therefore there was a question, we talked about it. If you have a chunk of ice at negative 20 degrees Celsius and it's in ice cold water, means at 0 degrees Celsius, what happens? What? You have ice at negative 20 degrees Celsius. It needs heat, not to melt, because it cannot melt at negative 20. It needs heat to take its temperature from negative 20 to 0. But until all of the ice reaches 0, it won't start melting. Are you listening to me? So the ice at negative 20 will be taking the heat from that ice cold water. I know it's unbelievable because we're thinking ice cold water doesn't have any heat. No, it does. It's comparison. So it'll be taking all the heat from the ice cold water, which is already at 0. So when you take heat from water at 0, what's going to happen? It's going to freeze. Water at 0 is at the freezing point, isn't it? You start taking heat, what's going to happen? It's going to turn into ice. So the ice that's already in there is going to create more ice. I know it's unbelievable, but that's what's going to happen. Did I explain it?
Yeah.
Will all the water turn into ice? No. The mass of ice will increase. And at the end, the temperature will again remain at 0. Now, why don't you see it so clearly? Because it has to be in a thermally insulated container for this to happen. In real life, we'll just have a piece of ice in water. You won't see it happening. Why? Because it's getting the heat from the outside. Did that make sense? So you always think about the real life thing and forget what I said. It's in a thermally insulated container. Conservation of momentum should be, conservation of momentum. I love the ballistic pendulum. It was even a lab. Remember the lab? There's so much involved in that. So I'm like, okay, let's have one problem. So this might just be, oh, this is conservation of momentum in 2 dimensions, where after collision one goes one way, the other goes the other way. That's usually what happens, isn't it? Okay. So what's conservation of momentum? Total momentum is conserved if there are no external forces acting. Yeah, that's what I've written. P is constant when net external force is 0. I'm giving you an example. 2 objects are moving with a certain velocity, and after collision their velocities change. Right? So here's my question. Does it have to be an elastic collision for momentum to be conserved? No, momentum is always conserved. We have 30 conceptual questions. Be careful. Momentum is always conserved, whether it's elastic or inelastic. Momentum is always conserved. But if it's elastic with an E, then kinetic energy is also conserved, which does not happen in real life, because when 2 objects collide, you always hear some sound, at least a small, that means energy is lost, or you see a spark. Neither, if it's neither, then be sure that there was a slight increase in temperature, maybe 0.1 Celsius. Okay, that's conservation momentum. Will you be able to do this? I can't ask. If the 2 objects stick together after collision, then it's a perfectly inelastic collision. What does that mean? Maximum kinetic energy was lost. I'm talking all this for the sake of the conceptual questions. The momentum. Now, in 2 dimensions, if you have 2 objects moving that way, like 2 cars colliding, may it never happen, but we know it does because of silly people. So, one trying to run the red light, you know what I mean? Choo! That kind of collision. And assuming that they get stuck together and go off at an angle, that's what I've drawn. So you can add their masses, they are stuck together, and they are moving with a certain velocity, which are called V sub C, C for common velocity. Will you be able to find that common velocity here? Yeah, you can do it in many ways, but yeah, it's better to look at it as along the x, along the y. So be with me when I ask you this. This one, I'm going to label the angle either here or here, assuming it's here. Let me take a look. I have not shown the angle yet. Please. Yay! Oh! Okay, so now I have the angle shown here. So when you take the component of this along the x-axis, what would it be? This along the x, would it be cosine or sine? What? Yeah, whatever you take the angle with will always be cosine. So it will be m1 plus m2 Vc cosine theta. I've not written that, therefore I can write now. That's the advantage of this. So I'll have to say along the x-axis, m1 v1 should be equal to m1 plus m2 vc cosine theta. Along the y-axis, m2 v2 should be equal to m1 plus m2 is the sine theta. All done. Who understood? Did you understand? Yeah? Then you can solve the math. Woman. Okay. Oscillations. Oscillations. Spring. Pendulum. Aren't these the 2 examples that we know? What's the formula for time period of oscillations in a spring? Now, for a spring, we always talk about a light spring, default. I'm never going to ask you about a heavy spring, no. Did we talk about forced oscillations? Yeah, where you could have one object vibrating that makes another one vibrate. That's what you mean by forced oscillations. Look at that word resonance. There is a conceptual question on resonance. What is resonance? Resonance is when one object makes another one vibrate at its own frequency. What happens during resonance? The amplitude of oscillation becomes large. And that's when I talked about opera singers who break wine glasses by singing. Have you heard of it?
Yeah.
How are they able to do that? Because the frequency that they produce matches the natural frequency of the wine glass. So when they produce that frequency, that wine glass responds and says, hey, that's my frequency. And they get so excited. The amplitude is big, glass is broken. That is true for anything, resonance. And that's how we tune radios. That's for UP2. Tune radios using electrical resonance. So this is mechanical resonance. That's electrical resonance. Forced oscillations and resonance, okay? So conceptual questions, what could I ask you? I could ask you so many. Here are a bunch of conceptual questions. You take a simple pendulum to the moon, where the acceleration due to gravity is 1/6 of that on the Earth, okay? By how much does the time period change? We're talking about the simple pendulum, which is the second formula. You take a pendulum to the moon, where the acceleration due to gravity is 1/6 of that on the Earth. Good? What's the new time period? At least tell me, would it be bigger or smaller?
Bigger.
Yep, the time period would be bigger. Why? Because this is in the denominator. Right?
Yeah.
So this would go up. Okay. Will it go up 6 times? There is square root here that so many students forget. Conveniently, they'll forget. Oh, on exam 4, there was a question. Oh my, I felt so miserable. It was 5. I remember the number was 5. I said it makes 5 oscillations in a second. Right? Do you want to know how many students took that as the time period? It's a shame. I said it makes 5 oscillations in a second. Did you hear me? 5 oscillations in a second. Is that even time? That is frequency. So the time period is 1/5. You don't want to know how many students, more than 50% of this class took that as the time period. And I was literally, my wife said, what happened? I was like on the desk. I'm like, what kind of engineers are these going to make? You're going to make good ones. That's why I'm insulting you. You got to read 5 oscillations per second, and you jump to, that's the time period. Be careful. I'm going to do the same on the final exam. Read the terms. What are they? Simple. All right, another conceptual question, this time about a spring. You take a spring. You stretch it by 5 centimeters. Next time you stretch it by 10 centimeters. By how much did the spring constant change?
The spring constant?
It didn't change because it's a...
Constant.
Not everybody will get that. Because immediately they'll go to F is equal to Kx. You know what I mean? And they'll be like, X doubled, so K should become half or some silly math idea showing that they're total. So that's what you got to be careful on the final exam. Like constants are constants. So I'll try that. I'll try many ways to check if you really know that for a spring, that is a constant. I'm going to try all that. Okay. That is one. Next. Motion in a vertical circle, is it? No, motion in one dimension, which we already did, didn't we? We worked out a problem. The first problem was that. So I will just go with this. This is the first problem that we did. Come on. minus h is equal to, you know how we got that minus, right? Okay, minus h is v naught t minus 4.9 t squared. I'm like, that's a question on the exam. You got to do it. That's what I'm trying to do there. Okay, next one. Projectiles. Projectiles. Did you say you love those?
Yeah.
Okay. Projectile motion, you just need to remember this. You know, when you review, things appear easier, right? Because they are easier. They are. First time you learn that, studied that, oh, you would have been like, what's going on? Okay, but now you know the velocity, the initial velocity should be resolved into horizontal and vertical. Okay, which component is not affected by gravity? Is it the vertical or the horizontal?
Horizontal.
Horizontal, not affected, meaning it stays constant. If it stays constant, then the only kinematic formula you can apply is that velocity in a time should give you the x. How many understood? Okay, good. That's what I'm going to write. I think I worked out 10 meter per second. First, you have to break that into 10 cosine of 30 and 10 sine 30. Right? Get those numbers and delta y. Oh, why did I say delta y is 0?
Because it goes up and then goes
Yeah.
back.
If it goes back from ground to ground, but what on the if on the exam I say ground to the table, then it's the height of the table. Be careful. What if I say it goes from the table to the ground? Then my negative of the height of the table. This is what I want my students to know. If you know this, I'm glad. Yeah, they got it. They got the difference between negative, positive, 0. I'm good. I'm good. This is not going to be a test on math. This is going to be a physics test. Okay. And so delta y is 0 in this case. And you're going to get this equation, agreed? King? Where did I get that 5 from? You know, 10 sine theta is 5, 10 sine 30 is 5, and 10 cosine 30 is 8.67. Okay? Done. Physics is easy, right?
Can't you do 2 times V naught over G?
To find the total time. Yeah. Not 2 times V naught over G. It's 2 times V naught sine theta over G. 2 times V naught sine theta over G. When theta becomes 90, you can use, because sine 90 is 1, okay? Right? Come, taking us to the next topic. We're moving fast now. Friction? We already talked about friction, didn't we? We talked about friction. Friction is mu k times Fn. In this case, it is mu k times mg. That's all I want you to know. Done. So, if I give you the initial velocity of an object, and I say, okay, let's do it. I give you the initial velocity of the object as 5 meters per second. No, let's make it 10. 10 meters per second, V naught. And it stops after rolling for 5 meters on a horizontal floor. And the mass of the object is 1 kilogram. Find the friction force. Go. Find the force of friction. There are 2 ways of doing this. If you use kinematics, you're going to take the roundabout method, where you'll have to find the acceleration first. But if you use the energy conservation, it's right there. Whatever kinetic energy it had at the beginning, it's all gone because of work done by friction, isn't it? Then all you had to do is, this should be in red, so you never forget. 1/2 times mass times velocity squared is equal to force of friction times delta x. Done. Who understood? Nobody.
How do you do it kinematics wise?
Wait, let's do the first easy one. Let's do the easy one. Did you understand the easy part? Yeah? Change in, this is called the work energy theorem. Remember? Work is equal to change in kinetic energy. Isn't the final kinetic energy 0?
Yes.
So I just took the initial kinetic energy, set it equal to the work done. I don't need to put the math in, right? I think you can already see it. Do you? That should be motion of objects. I don't even know. In a vertical circle? Yeah, in a vertical circle. This is of special interest. Because if it's a vertical circle, then you really have to understand stuff. Hey, what is the force that acts on any object moving in a circular path called? Centripetal force, and that's always mass times velocity squared divided by radius. So that is going to come here. But I stopped it right at the right point. Look at that. At the lowest point, there are two forces acting on it, Ft and mg, isn't it? What's the net force? Net force. Are you going to add them or take the difference? Tell me that. Take the difference because they are an opposite. So you're going to put Ft minus mg, and that net force must be equal to the centripetal force. Does that make sense? So remember, the centripetal force is the name of a package. It could be tension, it could be gravitation. I've told you this. It could be anything. But some students try to show centripetal force here. You can, but because that's the net force which we call centripetal. Okay. At the highest point, well, let me write this first. Okay. At the lowest point, we already decided. Okay, another thing that students go wrong because they memorize, some do. Will the velocity at the lowest point be the same as the velocity at the highest point?
No.
No. Where would the velocity be bigger? At the highest? Common sense. Or the lower? Where would the velocity be bigger? Oh, yeah, because when an object comes down, because of gravity, it's going to speed up. Okay, so do not forget to put V1 and V2. Some students just have one velocity. I'm like, you're not getting it. So I think I'm going to go to the highest point now. Okay, at the highest point, see what happened. Do you even have to memorize that? Don't we know that weight always acts vertically down? And that tension acts towards the center? Huh? So this tension should be up, this tension should be down, because tension has to be towards the center. It's in the string. And then, so would you add it? Yes, you would add it. So Ft2 plus mg is equal to that. And you know that velocity is always tangential. That's why I've drawn V1 and V2 tangential. And then I'm like, can you apply concept of energy here? Yes. Look what I'm going to do. Yeah, we have done all this. If you take A as the ground, what is the potential energy at A? Zero. And so wouldn't twice the radius be the height? Huh? So potential energy at that point should be equal to kinetic energy at this. That's all I'm doing. Potential energy at... Yeah, I'm writing it generally first. Potential energy at A plus kinetic energy at A should be equal to potential energy at B plus kinetic energy at B. Correct? Yeah. And then I'm like, okay, some of them become zero. Which one? Potential energy at A is zero. So you can do that. Well, I've not written that, but you understood. If I go ahead and write, then it would be 1/2 mv1 squared is equal to mg times 2r Is that right? No, it's not. Correct me. This is what students do.
V. The V.
You have to add the kinetic energy. Because at B, it is also moving. Don't forget that part. I've done this for such a long time that I know exactly where you will go wrong. You'll be like, potential energy there is equal to kinetic energy. Psh, gone. And when I'm grading, I'm looking for it actually. There it is. Okay, gone. That makes sense? Can we move on? Oh, you have a question? Somebody had a question? Yes, Drew.
Yeah.
This is angular acceleration and torque. I have to edit the recording. Angular acceleration and torque. I saw angular and got excited. Do you know that torque is I alpha? Just like, come on. Force is mass times acceleration. I wrote that just for comparison's sake. I want to remind you that mass is replaced by rotational inertia. Huh? Right? Okay, I don't know. What is that? Is that always the formula for rotational inertia? MR squared? No, that's for a particle. So if I give you a sphere, you have to know it's 2 by 5th mr squared. For a disk, just 2. No, just 2. 2/5 mr squared and 1 by 2 mr squared. That's for a disk. And for a sphere, solid sphere, 2/5. Just know these two. If I ask you anything about any other thing, I'll give it to you. Can you do that for me? Because that's usually where, because all atoms are considered to be spherical, see? Atoms, so we're going to use this so many times. And students are well versed with cross product. Whenever I ask a question on cross product, 90% of them get it right. So I might ask you a question. Here is an example. If you should be, hey, is the order important in a cross product?
Yes.
Yes, because one will be the negative of the other. So can you do R cross F for me right now and get that on the exam? Go. Did you get it? If not, here it is. Anybody got it? I was disturbing you, didn't give you enough time? You don't remember? Here it is for you to remember. IJK. 3, -4, 2. 2, 3, -5. Did everybody understand that part? Yes. Watch. It's all written here. J always negative. You have to put minus J. Now, I'm showing that step by step for Angel. No, because he had the courage to say, I didn't get it.
He said it before I could. I was about to say the same thing.
3 times 3. So I was talking about this minus. See that, Daniel?
Yeah.
Yeah. So here it's positive, here it's positive. This minus. And then,
So 14 and
yeah, so we got it correct. Yeah. That's it. False. No, I should not tell you because it might be something that begins. Impulse and momentum, what's the relation? Did you know there are 2 formulas for impulse? One is change in momentum. The other is force no, actually it's integral F dot dt. 2 formulas. That's what I'm trying to write. But I wrote it, yeah, okay, at least I'm writing it. So there are 3 things that I want you to know. So J stands for impulse. J, impulse, is change in momentum. It can also be average force multiplied by time because I'm showing you how we get that. And then I'm reminding you of something very important that students forget. You know what? All right, do that problem. 1 kilogram object moving that way at 40, coming back at 10, find the impulse. 1 kilogram, 40 meter per second, 10 meter per second. So something hit straight back like a baseball, whatever. What's the change in momentum? What is the impulse? Impulse is the change in momentum. So, what is the initial momentum? 40. What's the final momentum? Negative 10. Negative 10. So what's the change? 50. Some students think that being negative is bad, so they won't use. So please be careful. I'm telling you. I don't want you to be missing out because you forget the most important thing in physics, that direction matters, doesn't it? So that's what I'm trying to teach. There it is. Impulse is the change in momentum.
Is there a unit for impulse or no?
Yes, the same as for momentum. Because it's the change in momentum. And what's the unit? It's kilogram meter per second. Because momentum is mass times velocity, isn't it? Mass times velocity. Done. All right, good. Any questions on this? No, the recording is now 56 minutes long. Come on. Work. Work, power. Work and power. Easy. Work is force times displacement. Now remember, it's FD cosine theta. That's where students forget. You know, they'll just go, force times distance. No. You also have to consider the angle. If the angle is 0 degrees, what is cosine of 0? 1. So then, F times D. But if theta is 90, 0. So if I drag this object on this horizontal table, what's the work done against gravity? I move an object on a table, gravity is straight down, movement is horizontal, so the work against gravity is 0. So what am I working against? Friction. I'm telling you conceptually how I'm going to be setting it up. Power is work over time. Oh, I'm giving an example. Force is 10,000. Velocity is 36 kilometer per hour. Find the power. Go. Find the power. But how do you find the power?
Force times velocity.
Force times velocity. Yay! Why?
Because distance over time is.
Oh my, let's see. Okay, so in Bernoulli's principle, there are 3 parts: pressure energy, kinetic energy, and potential energy. If it's a horizontal pipe, you don't need the potential energy part. So this is all 3. This is the format in which I have taught you, isn't it? Okay, so if it's a horizontal pipe, I'm trying to say, look, water flowing through or something flowing through that, you can neglect GH. You need to take the other 2, which shows that where it's flowing faster, the pressure is lower. Who heard me? If it's flowing faster, the pressure is smaller. Conceptual question coming up. And you also know the equation of continuity. A1V1 is equal to A2V2. Huh? Area times velocity gives you the volume flowing in a second. So okay, if you have vertical pipes there, it'll rise up more where it's flowing slower. Look, I'm trying to show. Where it flows faster, it'll rise up less. Are you with me or not? Do you see this? Let me stop this. Do you see this? Where is it flowing faster? Which one is bigger? Velocity 1 or velocity 2?
Velocity one.
Velocity 1. Therefore, the height is smaller. Do you see? Conceptual question.
Because the pressure is lower.
The pressure is lower, where the speed is higher. If you don't know that, you don't know the nourishments. Sorry. So when wind flows over the roof of the building, inside the house, it's at rest, right? Over is moving so fast, wouldn't the pressure be lower? Over, that's why there's high chance of the roof getting lifted up. Although it's held by a million nails, that's nothing compared to the force of the wind. You all know that. Come on. Woo! That's why tornadoes and all that are, like, we're going through some now. Oklahoma and all that, so many people died.
Yeah. Our distribution center at Best Buy got torn up.
Wow. I don't want to be caught in a tornado. I don't want to be caught in any of nature's calamities because you can't stand them, but a tornado is horrible. It's like, up, gone. Am I recording all this sounds? Okay, go ahead.
I'm having a hard time.
All right, next topic, rotational motion. The chapter that you love so much. With all the kinematic formulas repeated. You remember?
Oh, yes.
Here. Omega naught t plus 1/2 alpha t squared. Kinematic formulas. Kinematic. Now this looks like I've gone through every chapter, but I've focused on sections of each chapter. Did you notice?
Mhm.
Yeah.
We thank you for that.
You are welcome.
I got a question.
Oh, gosh, Drew.
Your 2 alpha, like your 2AX formula.
Linear expansion. Everybody got that problem on volume. Not everybody. 2, 3 missed it. Remember where I asked you to find the change in volume? And the answer was 10 milliliter. On exam 4, I gave you the original volume. I gave you the volume expansivity. You know what a couple of students did? They did 3 times. Well, I'd been saying, even on the review, I said, if you're given the volume expansivity, don't multiply it with 3. You only do that if you're given the linear expansive. They don't pay attention. And they're like, I don't care. Volume? Okay, 3 times. Okay, so that's what I'm bringing in beta and alpha. What is beta? Volume expansivity. What is alpha? Linear expansion. What's the relation between them? So if you're asked to find the change in volume and I give you alpha, should you multiply it with 3? Yes. Daniel?
Is that L prime?
Yeah, that's not calculus. That's just nether length. Yeah. No calculus there. Now, I was talking about a specific question there where you had 2 different rods made of 2 different materials, and I wanted them to find the temperature at which both have the same change in length. I put those equal to each other. No, don't worry.
Russell, can you say that one more time about the beta and the alpha?
Okay, sure. Beta is volume expansivity, which is what you need when you try to find the change in volume, correct?
Mhm.
So, sometimes alpha is given, and you're asked to find the change in volume. So first, you have to find beta using 3 times alpha, and then use it. That's all. Agree? Be careful about that. Oh, ideal gas equation. Everybody likes this. That's easy. PV is equal to nRT. 100% got it. PV is nRT. More chemistry in it. You had some practice. N is the number of moles. But what everybody missed, I might ask the question again, was calculate the internal energy. Remember that question on exam 4? Man, made a mess of it. If I've not included it, I'm going to include that. We're coming towards the end of this. So here I'm trying to show you the units. The pressure should be in pascals, volume in meter cube. A couple of students made this mistake. They did not change the molecular mass into kilogram. What's the molecular mass of oxygen? 32. No, that's 32 grams. I know. I just finished grading. I remember. Not just you, Daniel. There are a couple more. No, I can give you the molecular mass if you ask me. But I'll give it to you as 32.
It was on the form.
It was.
I don't know chemistry. I don't know physics.
I know chemistry, I don't know physics.
Yeah.
All right. Gas laws. Boyle's law, Charles' law. So I'm saying, how do you get the gas laws from the gas equation? You know, you can get all the laws from this. Come on, easy. You keep temperature constant, you're going to get Boyle's law. Come on now. If you keep pressure constant, you're going to get this. Hey, temperature must be in what unit? Kelvin. If you keep volume constant, you get that. You got all the gas laws. So easy. Oh, I was trying to tell them, hey, if it's in Celsius. Do you see what I'm doing? If it's in Celsius, please. Oh, I was said, if the temperature changes from 23 to 46, will the pressure double? What I say, people on the exam, you know, you have to pay attention. All right. Where am I going now? Conduction. On exam 4, there was a question on the window pane. Somebody, if it's you, don't say it. It's not a good thing I'm saying. Somebody went and multiplied the length times the width times the thickness. I don't know what they're trying to do. Length times width times thickness, and found the volume, and the formula only has area in it. Isn't area just length times width? And why did I give you the thickness? Because of D. Temperature on the outside, temperature on the inside. It might come back, and I'm hoping that when I ask that, everybody gets it. See where I'm going? I'm like, that's an easy question. Let everybody get it. But no, I'm going to get it wrong, even if you ask me an easy question. What can I do?
I might be on the same boat as Daniel.
That's why you have to be listening. Oh, did you get a chance to write that? Yes, you did. Radiation was on exam 4. Radiation was on exam 4. Oh. So, 2, 3 again. Did not take the fourth power, or did not take this. Do you know what I mean? You wrote it, but didn't take the fourth power. Something. Hey, and if I do not give you the surrounding temperature, take it as 0 Kelvin. And if it's a black object, a perfect emitter, E is 1. A is the surface area. So many things to remember. If it's a sphere, it's 4 pi r squared. I graciously gave it to you on exam 4. I'm not going to give it again. 4 pi r squared. If it's a cylinder, what's the surface area?
It's diameter times.
No, cylinder. Look at the surface. Look, that, and that, right? How many surfaces does it have? 3. And this is pi r squared, so 2 pi r squared, and this is 2 pi r times length. Let me write it. So you understand. 2 pi r squared. Did you understand where I got that from? Plus 2 pi r, which is the circumference, times the length. I hope you understood. This is that part, these. Okay. Right? Change in entropy. Thermodynamics. Change in entropy. What change in entropy? Hey, which is a chapter we did not have an exam for? Okay, so I'm going to give you a take-home quiz. Yeah, it's for practice. We did not have thermodynamics on the final exam. So it's very important. It's not even for a grade. You just take it, but I am going to have 2 questions from that quiz on the final exam. Ah, now.
You said it wasn't gonna be on the.
No, it's not taken for a grade, but 2 questions from them.
Oh.
Because we did not have thermodynamics on exam 4, so I thought, you know what I'm trying to say. You need some more practice, do that. So change in entropy, that will be the last thing we're going to do. I'll put it on the exam. Let me see if that Archimedes was there. That was the last thing. So let's talk about Archimedes and then go back so we know that's it. Archimedes principle. What is the buoyant force? Weight of fluid displaced. How do you find weight? Mass times gravity. How do you find mass? Volume times density. I put everything together. Weight is volume times density times g. That's it. That's Archimedes principle. That being said, Archimedes principle is, you have to really understand to be able to do it. Like in the last 4th exam, I gave you mass in air, mass in a fluid. I said find the loss. All you had to do was find the difference, and I don't know what people did. They did everything.
They didn't do anything, because that was number 20.
I know what happened to you. Don't.
I kept getting my answer back to me as the same thing as lead, and I was like, I know I'm doing it wrong.
you are going in cycles because you're taking the same number, dividing it by. Because there is the solid and the fluid. That's the confusing thing for people. You have the solid and you have the fluid. So you have 2 densities in play. Density of solid, density of the fluid. So you have to really know what you're talking about. Anyway, that's Archimedes principle. Okay. Now, one last question. Change. Oh, that should be one more question. One problem, you're seeing it now. Let's give the easiest. Shouldn't make it that easy, right? Okay. All right. So let's go with a medium-sized one. All right. 100-gram copper ball. Forgive the grammar, I'm trying to make it short, okay? At 90 degrees Celsius plus, that means it's mixed with 500 grams water at 30 degrees Celsius. Find the change in entropy. Of the system. Find the change in entropy of the system. You start thinking about it. Copper? All right, so find the heat loss by copper first. Do it step by step with me, otherwise you're going to be in trouble. Heat loss by copper, what's the formula? MCAT? And MCAT would be 0.1, because I want it in kilograms, times 400, times change in temperature. Do we know the change in temperature? We don't. So what?
90 minus TF.
Oh, 90 minus TF.
It goes down.
Okay, all right. So if you want to keep it, it's always, I thought, final take away the initial, isn't it? So let's keep it the same way. Even yours will work, but I don't want to change it at,
It will work though if you do it like that?
yeah, I don't want to talk about it. It will.
For water, since water's only getting hotter, would you do TF plus?
No, wait. We'll get. So somebody do this calculation for me, please, and give it to me. So leave it there, and then heat gained by water is equal to MCAT again, huh? Which is what? 0.5 times, or give me that number, 0.85 times, go, TF minus 30. All right, give me the two numbers for that. That's why I wanted 4,200, but you didn't let me, so it's okay. I would have written it as 2,100.
Okay, so it's 2,092.5 for the one that's attached to TF minus 62,775.
775? Okay, so add both and set them equal to 0. Isn't that what we do? 40 TF minus 3,600 plus 2092.5 TF minus 62,775 is equal to 0. Yeah, do that, solve for T final, tell me what you get. It's okay.
303.6.
So 303.6. We got the average temperatures of copper and water in Kelvin. Now find the change in entropy. What's the formula? dQ over average temperature. What is dQ for copper now? MCAT? By average temperature. So what's MCAT? What was the mass of copper? 0.1. And I gave this as 400, I think, times. What's the change in temperature of copper?
31.13 minus.
90 minus 31.13.
You know, 31.13 minus 90, because it's always final minus initial. Yeah. So minus what? Okay. Bye.
58.87.
What do you get?
58.87.
58.87. Or I multiply that, divide by 333.6. Give me that. Negative something. Big deal. But do you see what we're doing? MCAT for copper divided by the average temperature of copper. So students go wrong here because they try to think about water here. We're only talking about copper. What do you get? Edson?
Negative 7.06.
7.06 joule per Kelvin. That's the unit. Do the same for water.
So is there an entropy value for every single item?
Yes.
Like the container, the water?
Yes. There is. We totally ignored the container because that would make it double hard. You know what I mean? So I only wanted to have the hot and the cold. Okay, what's the MCAT for?
5.
Now, you know what? Actually, if I say this, some people will get. You could use the same number because we know that the heat lost is equal to heat gained. But I'll let you do, what was it? 0.5 times what? 4185 times change in temperature was 31.13 minus 30 divided by the average was 303.6. Tell me what you get.
7.79.
Not negative. Not negative.
Oh, no, because
It's positive. Yeah. 7.79
Yes.
joule per Kelvin. And believe me, the positive must always be bigger than the negative. So, the final answer, net change in entropy. What do you do?
Just
Yeah. And the net change in entropy should always be positive. Can somebody give me that number so I can write that? Net 0.729 joule per Kelvin. You're going to see a question like this on the exam, worth 6 points. Did you understand or not?
Yes, sir.
Thank you very much. We got 80 minutes of recording. This will show up on Blackboard under exam reviews. You can look at it, fast forward, do whatever. Please don't curse. Thank you.